Hi children, this is your Skona Kiran Reddy. Welcome to 8th class mathematics. Exercise 6.1, first problem. What will be the unit digit of the squares of the following numbers? Here we are given some numbers. We need to find out in the square of these numbers what is the digit in units place. That is what we need to find out. So here we are given so many numbers. Before going to answer these questions, let us first look at the squares of first 10 natural numbers. So 1 square equal to, we know that is equal to 1, 2 square equal to 4, 3 square equal to 9, 4 square equal to 16, 5 square equal to 25, 6 square equal to 36, 7 square equal to 49, then 8 square equal to 64, 9 square equal to 81, and then 10 square equal to 100. Now if you take 1 square, that is equal to 1. Now whatever the number you take, if the digit in units place is 1, then square of that number has 1 in its units place. Suppose if we take 91 square, the value of this one is 8281, 8281. So digit in units place is 1. Now similarly, if you take whatever the number 71 square, so whatever the number may be, the digit in units place will be 1. Like that, it works for all the remaining numbers also. That means, if you take 2 square equal to 4, if you take something like 4272 square, so whatever the square may be, the digit in units place will be 2 square means 4. So that is the digit in units place. Now if you observe 4 square equal to 16, the digit in units place is 6. So if you take any number with 4 as its units digit, suppose if we take like 7284, suppose square of this number, this is equal to 4 square is how much? 16. In 16, what is the digit in units place? 6. So digit in units place will be 6 for this number also. By using this strategy, we can find out the units digit of the squares of these given numbers. Now if you take first one, 81. So the digit in units place will be, if you take 1, 1 square is 1. So the digit in units place is 1. So the answer for first question is 1. So answer is 1. Next, if you take second one, we have 272. The digit in units place here is 2. So 2 square is 4. For this, the answer is 4. So that means digit in units place in the square of 272 is 4. Now third problem, 799. If you take the square of this number, just take the digit in units place, that is 9. 9 square, you observe here, 9 square is 81. So the digit in units place is 1. So in the present number 799 also, if you take the square of 799, the digit in units place will be 1. So the answer for this one is 1. Now next number is 3853. So here we have 3 in its units place. If you take 3 square, that is 9. So in the square of 3853, the digit in units place will be, so that is also 9. Now let us take the fifth one, 1234. The digit in units place is 4. 4 square is 16. In 16, the digit in units place is 6. So for this number also, if you take the square of this number, the digit in units place will be 6. Next, sixth problem, 26,387. For this, the digit in units place is 7. 7 square is 49. So 9 is the digit in units place. So for this number also, if you take the square, it has 9 in its units place. Seventh problem, 52,698. Here we have 8 in units place. 8 square is 64. In 64, the digit in units place is 4. So for this number also, the square of this number has 4 in its units place. Eighth problem. 99,880. So square of this number has 0 in its units place. Ninth problem. 12,796. So here the digit in units place is 6. So square of this number has 6 in its units place. Now 10th problem. 55,555. So the answer for this one is, what is that? 5. Why? Because digit in units place is 5. Square of 5 is 25. So it has 5 in its units place. Like that, by using this strategy, we can find out the digit in units place for the square of any number. Exercise 6.1, second problem. The following numbers are obviously not perfect squares. Give reason. Before going to answer this question, first let us take the squares of first 10 natural numbers. We know that 1 square equal to 1, 2 square equal to 4, 3 square equal to 9, 4 square equal to 16, 5 square equal to 25, 6 square equal to 36, 7 square equal to 49, 8 square equal to 64, 9 square equal to 81, 10 square equal to 100. Now if you observe the digits in units place, 1, 4, 5, 6, 9 and 0. These are the only digits in units place for square numbers. So other numbers, what are the other numbers? 2, 3, 7 and 8. If you have any of these digits in units place of any number, then it is not a perfect square. So now let us see the first one, 1057. Here we have 7 in its units place. So if we have 7 in its units place, it is not a perfect square number. So here what can we write? The digit in units place. The digit in units place equal to 7. So therefore 1057 is not a perfect square. Perfect square. Now if you take the second one, so 23,453. Here digit in units place is 3. So it is not a perfect square. So similarly, we can use same strategy for all these numbers. If you take third one, digit in units place equal to 8. So it is not a perfect square. Fourth one, digit in units place is 2. So it is not a perfect square. Now let us see the fifth problem. In this, we have 0 in its units place. So it may be a perfect square. Why? Because you see here, if it is 0 in its unit place, that number may be a perfect square. Now let us observe 10 square. 10 square equal to how much? 100. 100 square equal to how much? 10,000. Now 1000 square equal to, so here we have 3 zeros. In the square of this number we have 6 zeros. Now if you observe all these square numbers, 10 square equal to 100 means we have how many zeros? 2 zeros here. In 100 square we have how many zeros? We have 4 zeros. In 1000 square we have how many zeros? 6 zeros. That means if you take 10 or 100 or 1000, its a square number contains even number of zeros in it, 2, 4, 6, 8 at the end. Here in fifth problem we have 64,000. Here we have how many zeros? 3 zeros in the end. If it is a perfect square, it has 2 zeros or 4 zeros. That means even number of zeros. Here we have odd number of zeros. That is why it is not a perfect square. So what is that we need to write here? Number of zeros. Number of zeros is odd. So therefore 64,000 is not a perfect square. Now let's go to sixth problem. In sixth problem also we have 2 in its units place. So this is not a perfect square. Let us go to the seventh problem. In seventh problem we have number of zeros, that is equal to 3. So number of zeros actually at the end. So at the end equal to 3, which is odd, comma odd. So therefore 2,22,000 is not a perfect square. Now if you go to 8th problem, this is for 7th problem. For 8th problem, you see number of zeros at the end. So number of zeros at the end equal to 1. So which is odd. So therefore the given number, so this is not a perfect square. So that means if a number has zeros at the end, then if those zeros are even in number, that means at the end it has even number of zeros, then only there is a possibility of a perfect square number. If there are odd number of zeros, it will not be a perfect square number. Exercise 6.1, third problem. The squares of which of the following would be odd numbers? First problem. 431 square, let us take. This is equal to 431 times 431. Here both are 431 and 431. Both are odd numbers. Odd number multiplied by odd numbers. That means if you multiply two odd numbers, we will get odd number. So this is odd number. For second one, 2826 square, which is equal to 2826 times 2826. This is even number and this is also even number. So the product of two even numbers is equal to even number. So this is not odd number. Next problem, 7779 square. This is equal to, in square of this one also we have, square of this number is equal to 7779 times 7779. Here these two are odd numbers. So odd number multiplied by odd number gives us again odd number. Now then fourth problem, 82,004 square. So here 82,004 is even number. So even number multiplied by even number gives us even number. So from this we can conclude that square of odd number is again odd number and the square of even number is again even number. Let us go to the next problem. Observe the following pattern and find the missing digits. Here 11 square equal to 121, 101 square equal to 10,201, like that we have. Now if you observe the pattern at left side, first 11 square we have, then 101 square, then 1001 square. That means here we have 1 0, here we have 2 zeros, then 4 zeros, and then we have 6 zeros here. Here 6 zeros, here how many? 4 zeros, here we have 2 zeros, and here we have 1 0. Now if you observe the right side patterns, 11 square is 121, okay. Then 101 square equal to 10,201. That means if we include 10 in between these two ones, we need to include 10 between the digits of this 121. So that means 121, in between 1 and 2 we put 10, in between 2 and 1 we need to put one more 0. Similarly, if you observe the next one, here we have 2 zeros and here we have 2 zeros. So then next one, here in this one we have 4 zeros. So we need to put 4 zeros here, here also 4 zeros. Then in the next last problem we have 6 zeros. So first write 1, then write 2 here, then write 1 here. In between 1 and 2 we need to put 6 zeros. 1, 2, 3, 4, 5, 6. In between 2 and 1 also we need to put 6 more zeros. 1, 2, 3, 4, 5, 6. Exercise 6.1, fifth problem. Observe the following pattern and supply the missing numbers. Now observe the pattern, how the pattern is going on. So 11 square equal to 121, that is in the first row. In the next row, 101 square equal to, you see here, 10,201. So that means if you insert 10 between this 1 and 1, at right side also you need to insert 10 between 1 and 2 and 10 between 2 and 1, like this. Now let us see 10101. So that means you write 3 ones and between 2 successive ones we need to insert 10. Now right side you see we have 1, 2, 3, 2, 1 and then between 2 successive digits we need to put 10. If this pattern continues, then the square of next number will be write 1, 2, 3, 4, then 3, 2, 1. Between 2 successive digits put 10 like this. So this is the answer. Now you see here in the next number, in the square of the next number at right side we have, you see 1, 2, 3, 4, 5, then 4, 3, 2, 1. That means there must be 5 ones. So 1, 2, 3, 1, 2, 3, 4, 5. Between 2 successive ones we need to put 10. So 0 here, 0 here, 0 here, 0 here. So this is the answer. Let us go to the next problem. Using the given pattern, find the missing numbers. Observe the pattern. 1 square plus 2 square plus 2 square equal to 3 square. 2 square plus 3 square plus 6 square equal to 7 square. 3 square plus 4 square plus 12 square equal to 13 square. Now 4 square plus 5 square blank square equal to 21 square. In the first row, so here in the first term the base is 1 and in the second term base is 2. Multiply these two, 1 times 2 which is equal to 2, that is the base of third term. Now let us check, is this same in the second one also, second line also? Let us check. 2 is the base and here 3 is the base. 2 times 3, 2 times 3 that is equal to 6, that is the base of third term. Yeah, that's correct. Now let us check for the third one. 3 square plus 4 square plus 12 square equal to 13 square. 3 is the base in first term, 4 is base in second term. So 3 times 4 which is equal to 12, that is the base of third term. So in the same way if you observe next line, 4 square plus 5 square we have. So base of the first term times base of the second term. That means 4 into 5. So 4 into 5 equal to 20. So this is 20 square. In the next line also 5 square plus, actually to get 30 here we need to multiply 5 with 6. So 6 square. Now in the last row 6 square plus 7 square plus 6 times 7, that is 42. So 42 square. That is at left side. Now what will be What will be at right side? Let's check. Let me erase all this. Here we have 3 square here. Here we have 7 square. Here 13 square. Then 21 square. Then 31 square. You see here 2 we have. 2 plus 1 is 3. So 3 square here. Next 6 we have here. 6 plus 1 7. So 7 square here. Similarly 12 we have 12 here in the third line. 12 plus 1 13. So 13 square. Same pattern applies in the next rows also. So in the last row 42 we have as the base of the term. So 42 plus 1, that is 43. So that is equal to 43 square. Let us go to the next problem. Exercise 6.1, 7th problem. Without adding, find the sum. So first problem is 1 plus 3 plus 5 plus 7 plus 9. This is equal to, we know that sum of odd numbers starting from 1 equal to square of how many numbers we have. Square of how many terms or how many numbers we have. Here we have 1, 2, 3, 4, 5 terms we have. So this is equal to 5 square, which is equal to 25. Next, second one. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. So that is equal to, just count how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is equal to 10 square, which is equal to 100. Now in the same way, if you go to the third problem, how many numbers are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that will be equal to 12 square, which is equal to 144. See how beautiful the mathematics is. Let us go to the next problem. Express 49 as the sum of 7 odd numbers. We know that sum of odd numbers starting from 1 equal to square of how many numbers we have. So that means, suppose we have 1 plus 3 plus 5 plus 7 plus 9 plus 11. This is equal to, just count how many numbers we have. 1, 2, 3, 4, 5, 6. So this is equal to 6 square, which is equal to 36. In the same way, if you take 49, so 49, that is equal to, that is nothing but 7 square. So it can be written as 7 consecutive odd numbers starting from 1. So this will be equal to 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. So how many? Let us count. 1, 2, 3, 4, 5, 6, 7. That's it. All these are odd numbers and we have 7 odd numbers. Sum of these 7 odd numbers is equal to 7 square, that is equal to 49. Similarly, if you take 121, that is equal to, we know that 121 equal to 11 square. So we need to write 11 consecutive odd numbers starting from 1. So 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Let us check how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 only. So let us write, after 19 we have 21. So we have here 11 odd numbers and the sum of these 11 odd numbers equal to 11 square, and that is equal to 121. And one more thing, here we are given express 49 as sum of 7 odd numbers. We are not given 7 different odd numbers, like that we are not given. So we can write 49 as, you see here, 49 equal to 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7 also. All these 7s are odd numbers, and we have how many 7s? We have 7 sevens. So 7 sevens equal to 49. So sum of 7 odd numbers equal to 49. The condition is satisfied. So we can say For first one, this is also as the answer. We are not given, we need to write different odd numbers or consecutive odd numbers, like that we are not given. So this answer is also correct. Similarly, if we take second one, 121, this is equal to, we know that this is equal to 11 square, and 11 plus 11 plus 11 plus, like that, if you write 11 11s, 11 terms, yeah, this is also correct. Let us go to the next problem. Exercise 6.1, ninth problem. How many numbers lie between squares of the following numbers? We know that between squares of any two successive numbers, how many numbers we have? So suppose if we take 4 square and 5 square, so numbers between these two equal to, take the difference of 5 square and 4 square, that means 5 square minus 4 square, that is equal to 25 minus 16, which is equal to 25 minus 16 is 9, 1 less than this number, that is 8. So there will be 8 numbers between 4 square and 5 square. So similarly, if we take first one, 12 and 13 we have. So here what we need to take is 13 square minus 12 square. So 13 square equal to how much? 13 square equal to how much? 169 minus 12 square is 144, which is equal to 25. So 1 less than this one, 1 less than 25, that is equal to 24. So there will be 24 numbers between 12 and 13. So therefore there are 24 numbers between 12 square and 13 square. Now here one thing I need to say. So to find out the value of 13 square minus 12 square, I wrote 13 square as 169 and 12 square as 144. Here 12 and 13 are two successive numbers. So if we use a square minus b square identity in this case, that is equal to a plus b times a minus b, that will be very easy. In this case, 13 square minus 12 square equal to 13 plus 12 into 13 minus 12, which is equal to 13 plus 12 is 25 times 13 minus 12 is 1. So this is equal to 25. So to find out the difference of squares, we can use this strategy. Let us go to the second problem. Here we need to find out, in the second problem, we have 25 and 26. So we need to find out 26 square minus 25 square. As I said earlier, we can use a square minus b square equal to a square minus b square equal to a plus b into a minus b identity. So this is equal to 26 plus 25 times 26 minus 25. So which is equal to 26 plus 25 is 51 into 26 minus 25 is 1. So this is equal to 51. Now we need to take 1 less than this 51. So 1 less than 51, which is equal to 50. So therefore there will be 50 numbers between 25 square and 26 square. Now let us go to the third problem. 99 and 100. So we need to take 100 square minus 99 square, which is equal to, as I told earlier, we can use a square minus b square. A square minus b square, that is equal to a plus b times a minus b. So 100 square minus 99 square equal to 100 plus 99 into 100 minus 99, which is equal to 199 into 1, which is equal to 199. So we need to take 1 less than this number. So 1 less than 199, which is equal to 198. So therefore, there will be 198 numbers between 99 square and 100 square. We can do these problems by another way also, by using the formula. Suppose n and n plus 1 are two successive natural numbers, then between n square and n plus 1 whole square, so between n square and n plus 1 whole square, there will be 2n natural numbers. There will be 2n natural numbers between n square and n plus 1 whole square. Now by using this formula, suppose if you take the first one, we can take n equal to 12 and n plus 1 equal to 13. So that we will get 2n equal to 2 times 12, which is equal to 24. Therefore, there will be 24 natural numbers between 12 square and 13 square. So number of natural numbers between 12 square and 13 square equal to, that is equal to how much? 24. Now second problem. In second problem, let us take n equal to 25 and you will get n plus 1 equal to 26. So from that 2n equal to 2 into 25, which is equal to 50. So there will be 50 natural numbers between 25 square and 26 square. So we can write number of natural numbers, or we can say number simply, natural numbers between 25 square and 26 square equal to, that is equal to how much? 50. Now let us take the third one. That is 99 and 100. So here let us take n equal to 99, so that n plus 1 equal to 100. So from this we can get 2n equal to 2 into 99, which is equal to 198. So therefore there will be 198 numbers between 99 square and 100 square. So like this also, by using the formula we can do these problems. Like that, if you apply logic while doing the problems in mathematics, we can solve the problems in mathematics in very easiest manner. Hope you enjoyed the class. If you enjoyed the class, please subscribe my channel. Thank you one and all.